Yeah. So next I was talking about whenever compiler generates assembly, assembly will contain 4 components. I didn't explain any of these components, only I listed. One I said assembly manifest. Assembly manifest. Second you call metadata. Third you call CIL code. And fourth is called resources. What it is, how it is, nothing I discussed, nothing. It was just an overview part we have come up to study about the compilation process. Today we are going to go with the second process that would be for execution concept now. Now we are going to learn. Now execution mein what happens is that assembly which is generated by compiler, assembly which is generated by compiler, what will happen? It is handed over to CLR. And what CLR is going to do, let us describe here. CLR will hand over this assembly. Will hand over this assembly to one of its component. So inside CLR, approximate I'm saying, we have around 11 to 12 components. Coming classes, I'm going to talk on all of them. Yes. Yes. CLR internal contains what? One component. Okay. And that component is called JIT compiler. Inside where? CLR. Among that 11 to 12 components, this is one component. What is the name of the component? Let me describe here. JIT compiler. Yes. JIT compiler. And you describe here as just-in-time compiler. Yes. Just-in-time compiler, JIT compiler. What it is? One of the components available where? Inside CLR. And remember one more point as well here. JIT compilers are of types again. JIT compilers. At the end of this topic, I'll discuss about them. 3 types of JIT compilers will have. 3 types. So never get confused, please. Here I was talking about language compiler here. Here I'm talking about compilation that happens at execution level. This is 2 different approaches, 2 different concepts. 2 different concepts. Okay. And remember, this JIT compiler, what it will do, let me describe here. Here I'll write. What it will do, here you describe. What? Translates required. What it would do? Translates required code in execution. Translates required code in execution. Execution to what? Here I come up. It will translate the required code in execution to native code. Yes. Native code. Yeah. Let me describe that. Here I write native code. Yes. And what is this native code called? Yes, already we studied. Machine language. What do you call? Machine language. Yes. And this is for whom? For operating system, for OS. Yes. For OS. And now let me explain you. If you are aware, fine. If not, at least remember the example, what I'm explaining you. See, in programming languages, you would find something called if condition. If condition. You write like this, if condition. We open a block. We write some 10 lines of code here. Then we write something called else. Then we write some 19 lines of code here and we close this. This is the code I write. Now, interesting thing is, when my program is in execution, when my code is in execution, if at all condition that you have mentioned is true, if the condition is what? True. What will happen? JIT compiler will translate only these 10 lines of code, required code in execution. What is needed, only that part it will translate. What is not needed, it will just ignore it. Okay, that is the reason it has been called JIT compiler. Acha, another interesting thing I'll say. This is another speciality. I'll just extend this and I'll explain you what is happening. Extension. Yeah. And this extension, I'll just draw one. Okay. What it is, I'll explain. Just wait. Yeah. Now remember, something interesting is programming languages also have something to learn about loops, we say. Loops. In that loops, one we have while loop. And I say I less than or equal to 5. And I initiate my I as 1. Okay. And again, what I'll do, I'll open the block. I'll code here of some 12 lines. 12 lines code I'll write and I close this. And we know by seeing that is one loop. Loop is repeated execution. And it is going to repeat for 5 times. 5 times. Starts from 1, ends with 5. 5 times. What JIT compiler will do now? JIT compiler. First time JIT compiler, when it gets this while loop, what JIT compiler will do? It will translate. Because condition is true. JIT compiler translate the 12 lines of code. 12 lines of code. JIT compiler will translate to what? Native code. It will translate to native code. And remember, after translating it to native code, remember that 12 lines of native code, it is going to store. Here I'll write store into. Where it will store? It will store into. Where? It will store into buffer or cache memory. Stores into buffer or cache memory. For what? That is what we have. Reusability. Reuse of code. Reuse of code. And what it will do? This 12 lines of code, it will convert to native code, and the 12 lines of native code will store in buffer. First time. Still, it should run this 12 lines of code for 4 times. Now, from second time onwards, direct this code will be executed. JIT compiler will not do repeated task. Once it will translate, Once it will translate, and after that, the translated code, it will keep in buffer, and then it's over. That's it. Again and again, JIT compiler will not repeat the task, will not repeat the work. Okay. Yeah. You have any questions that you would like to ask me on it? Go ahead. If not, I'll take up next part where I discuss now about a C# holding something called assembler. I'm going to talk on that now. Next part. Yeah.
Sir, one question.
Yes, go for it.
Sir, even the variables declarations, even those get stored in the buffer or cache?
Actually, the point is that story is different. Actually, Nikhil.
Okay.
But when we start program, I'll explain you because C# is going to deal with 3 types of memory concepts actually. Right.
Okay.
So when I start program, I'll explain you at that time. One something called stack memory. One is
Okay.
called heap memory, and third is called static pool. So that
Static.
is different story that I'll explain you later. Okay.
No worries.
Yeah.
Okay.
Yeah. Okay then. Here I'll just mention so that instant here itself you'll have a reference. Okay. What is it? Here I'm going to write types of JIT compilers. Okay. Types of JIT compilers. Right. All 3 I'll write. All 3. One is called normal JIT. Normal JIT. What it will do? Translates required CIL code to native code, and that code is stored in buffer or cache for reusability. Yeah. There is normal JIT. Second, we have that you call as pre-JIT, we say pre-JIT. Translates complete CIL code to native code. Complete. Lot of difference we have in it. Lot of difference. 2 different approaches. Yes. One is going to translate required code, I said. Required code. Okay. One I said is going to translate total code, I said. Total code. Pre-JIT will do that job. And finally, they made available with the third one as well. Third one. And that which you call as iconojit, we say. Third one. What do you call this as? Iconojit. Actually, that word we are using in short, but actually you can call that as economic. Iconojit. That is one more type we have. Iconojit. And what it will do, let us write now. Yeah. What do you say? Translates required CIL code to native code, and the code is not buffered. Yeah, that is the difference. There's a difference. Normal JIT, it will be stored in buffer for reusability. Here, it is not stored in buffer, so it is not reusable. That's three types of JIT compilers we have. Normal JIT, pre-JIT, econo-JIT. The one which we took in this architecture, JIT compiler, obviously, that was related with normal JIT compiler. Normal JIT compiler. Yes. Now, next part I'll explain. Next part. Yes. And what is it we have is, here we are going to learn what is reverse engineering in .NET. Okay. So let me come up with this. Open paintbrush. Heading you write. Third architecture. And don't forget, please, the topic what we have started last session after completing the introduction of visual with respect to C#.NET introduction part. We actually have come up with this stuff yesterday. Yesterday we studied all this. Here we were actually here. Platform independent. In this platform independent, as of now, three architectures we covered. One was architecture of platform independent. This we covered. And then architecture of compilation and execution. This we covered. And then we studied, now we are going to study about architecture of compiler and assembler. And why it is called, why that you refer as, what do you call, reverse engineering, that also you'll get to know in this example, right? Architecture of compiler and assembler, that is reverse engineering in .NET. Yes. Compiler and assembler, both. Yes. Reverse engineering in .NET. And now remember what actually happens. And this concept which I'm going to show you, so this is not possible actually in old programming languages. This is possible in Java. This is possible even in C#.NET, right? But for that also we got some precautionary measures, right? Some tools are introduced. We'll discuss at the end of this topic what it is. Fine. This is C#.NET application. Okay. This one is, yeah, somewhere here I'll write. What is this? C#.NET application. Yes. Yes. What do you call this as? Source code. Source code. And this code we hand over to compiler, obviously language compiler. Yes. Language compiler. Language compiler. And what this compiler will do is, this compiler will generate what? CIL code in binary format. CIL code in binary format. Okay. And where does this store? We already studied. This is part of assembly. Compiler created file you call as assembly, which will have either .exe or .dll extension. Assembly. And what is this file called? PE file. Last class we studied PE file. Portable executable file. Okay. Now, till this point is one level of discussion. Now remember, reverse engineering. What is it called? From where you got this CIL code? From where did you get the CIL code? Obviously, from source code. From source code. Who gave the CIL code? Language compiler. Okay. Now point is, due to some reason, I lost this file. I lost this file. Source code, the main code file, which I created. I lost it. Okay. I lost that file. What next then? You have only exe now. That is CIL code. And after losing that file, what I felt is that in the program, I would like to make some changes. I would like to make some changes. But already you lost the code. Already you lost your source code. You have only assembly with you. Only exe is there. And after losing that source code, you are realizing that you want to make some small changes in the program. Fine. Remember, even though you lost your source code, still C#.NET supports. What it will support? This process. What is that you lost? What is that you lost? Source code you lost. Our written program. Our written program. Okay. What do you want to do now? Yes. Now I lost my source code. No doubt, I lost my source code. And after that, I felt that my program is generating some output. My program is generating some output. And in that output, I would like to make some changes. I would like to make some changes, but I don't have source code. So we are going with alternate mechanism. So in order to make changes into CIL code, which is in binary format, so to do the changes, first you should convert. You should convert the CIL code, which is in binary format, convert to text format. To do this, C# provides one tool named ILDASM, and it is exe file, which you call as API. You call as what? API. ILDASM. Exe. That is what? API. What it will do? Yeah, it will convert that CIL code. CIL code, what did I say? That is what you call byte code, I said. Byte code, common intermediate language. And that ILDASM tool will support us to convert CIL code, which is in binary format. It will allow you to convert into text format. Binary format, it will convert to what? Text format. CIL code text format. And after converting to text format, now you can make changes. Now you can make what? Changes. So after converting this assembly code in binary to text, now you can make changes. And after making changes, again, you should reverse this now. Convert this CIL code, which is in text format, back again to binary format. Reverse. Yeah, from what to what you're converting, that is important, please. You want to convert. From where to where you want to convert? You want to convert text format to what? Binary format. For that, we are provided by one API called ilasm.exe. This is API. So what is ILDASM will do? Let me describe here for your reference. ILDASM, intermediate language disassembler. Disassembler. And one more is ILASM, that is called intermediate language assembler. Intermediate language disassembler and intermediate language what? Assembler. Okay. And remember, since we are converting CIL code binary to CIL code text. This process, what you are doing in the absence of this, in the absence of what? In the absence of what? Source code. In the absence of source code. This process we call as reverse engineering. Usually, this cannot be done in old programming languages like C, C++. Reverse engineering. Yes. Now, what Microsoft has done then? Yes. Now, let me talk on this tool. Right. What is that Microsoft has done? Let me describe. Yeah. Now, remember, Microsoft has introduced one special tool so that they can avoid reverse engineering. They can avoid. And what is the tool? The tool is called .fuscator. Name of the tool. .fuscator. And what this tool will do? Describe. This tool introduced by Microsoft to avoid reverse engineering. Okay. And what this tool will do? Describe. This tool will create a key on assembly and add some code into it, which creates confusion and restricts reverse engineering. Restricts what? Reverse engineering. Hence, applications developed in .NET are secure if you have this tool. So Microsoft introduced this tool to protect the code to avoid reverse engineering. And in Java, we got one tool introduced. One tool they introduced in Java to even protect reverse engineering in Java. So they got their own tool for Java. If you want to provide security, if you want to avoid reverse engineering, they use one tool. To avoid reverse engineering, for us, we use .FirstScatter. Java mein they use something called code protector, something they call. That is one tool which is introduced to avoid reverse engineering. Yeah. This is what platform independent is. Yeah. Any questions that you want to ask me? Go ahead.
Good evening, sir.
Yeah, go ahead.
Sir, I have a question.
Yeah.
Like, if you open the drawing, I can just tell, sir, please.
Sorry.
Actually, yeah, this just close it. Yeah, sir. Using ILDSM.exe file, we are converting the binary code to CI text code.
Yes.
So why this CI code text code? Why it not take the position as a source code in the first that CNet dot application? Means my dot is that after converting binary code to CI code, why are again moving back to CI code to ILSM.exe? Why not I put this text file as a source file in the first part? Then again we will go to language compiler, convert the thing. Can we do this one, sir?
No. Source code will be given to language compiler. Language compiler will generate CIL code in binary format, that is fixed format. That cannot be altered. That is fixed. That is the job of compiler. And it is not in the case of .NET. It is the work of compiler in all the programming languages. Only difference that you could find is that compiler generated code differs from one language to another language. When we used to compile our program in C language, even C language compiler used to generate one file, and there we used to call that file as object file containing object code. Here you are calling that file created by compiler as assembly that will store CIL code in binary format.
That means this is the process.
Initial part, compiler job only. After getting that CIL code in binary, then the next level work starts with those two tools, ILDASM, ILASM. And this is for your reference, for your knowledge, I'm saying. Definitely, since I don't have .FirstScatter in my machine, we will experience this practically in my coming classes. Okay. Chaitanya, Nikhil, Sindhu. Are you all clear with it? Sindhu is your first session today, right? Okay, Nikhil.
Yes, sir, clear.
Yeah, okay. Sindhu, Jogi. Am I audible to you? Yeah, unmute your mic, please. You have any questions to ask as this is your first session? If today's class you feel that it was informative, you could make out something of it. You can ask recorded sessions from the management, from last 2 to 3 sessions, whatever I completed. You can collect those videos and you can go through them if you feel comfortable of today's session.
Sir, I have another one question.
Yeah, go for it.
You written notes for dot frustrator
Ah.
that this tool will create a key on assembly and add some code into it,
Ah.
which create confusion and restrict reverse engineering. Okay,
Ah.
I understand this tool will restrict the reverse engineering,
Yeah.
but I don't understand what is the meaning which creates confusion. That
What?
you written, sir, which
Huh.
creates confusion
Huh.
and restrict reverse engineering.
Huh.
In the latter part, I understand, okay, using this tool, we will not go back with this reverse engineering part. But the first part you written, sir, which create confusing. Can you explain what?
See, I'll give you one simple example. Simple example. I have one word, one sentence. Welcome to world of computers. This is one sentence. You, me, all can read this. All can read this. Now what I will do, I and Chaitanya will come to one conclusion that we'll write some code, we'll write some text which can get understood only by me and Chaitanya. No one else should be in a position to detect that code. No one should be in a position to understand that code. So what I will do, I'll represent the text like this. I'll write like this. Now I and Chaitanya knows what it is. We know, we have written a code for it. We know what exactly the meaning of it is. You, me cannot understand. This is what others should not detect. Others should not understand. I want others to lose readability. Others should not be in a position to translate our code. What I did in this to get that code, I and Chaitanya only know. So I added some code. So I added some extra code. I added some type of key, which is confusion for others. But if I give this document to Chaitanya, Chaitanya can decode this. You understand? So such type of additional code dot frustrator will add in our CIL code. And because of that added extra code, now problem, IL loses. IL cannot understand now what to do, how to convert that to text, that it loses, and that will avoid reverse engineering. No problem, Sindhu, no problem. Now, is this fine? Then you can unmute yourself. Let him complete his clarification of doubts. Then you can talk to me. Okay.
Okay, sir. Understand. Means just like an encryption, decryption like this.
Exactly. Exact term, perfect term you have used. That is what you call encryption of your CIL code. Okay.
Okay,
sir. Right. Now we'll talk about second feature of C#.NET. That is what you call language independent. And what you learn here is .NET application logic can be developed in any .NET framework compatible language. No one will say that you have to write .NET code only in C#, only in VB. No, it's not like that. No, not at all. If you know Perl language, PERL, Perl language. So Perl language has one .NET support. .NET support. Then you know Perl language, then you can use Perl.NET. And there you can write the program. No, it's nowhere written that every person around the globe has to use only C# and VB. No, not at all. Hence, .NET is called language independent. And what we find today, approximate of 60 plus languages supporting .NET framework. In that 60 plus languages provided by Microsoft. One is Visual C# .NET, Visual VB .NET, Visual C++ .NET, Visual F# .NET, Microsoft developed languages. And there are many third-party languages. It means other companies developed languages. That gives very big list. Those I'll just make a list of few of them. One you call, just now I took example, Perl.NET, Python.NET, APL.NET, Pascal.NET, COBOL.NET, Eiffel.NET, and what else here? Smalltalk.NET, PHP.NET, JSharp.NET, Haskell.NET. What else we have? Oberon.NET. And yeah, some of those things that I recollected have written for your reference. These are all third-party languages. These are also supporting what? .NET framework. That is the reason you can write a .NET program logic in even third-party languages. Not necessary. It should be only a part of Microsoft-related language. Right? Okay. Next, we have something to discuss about language interoperability. The most important part of .NET. Most important part. Language interoperability. I'll just write definition. Tomorrow's class, I'll come up with this with architecture. Okay, so that detail you can understand. What do you call? It is a concept of developing .NET application with the help of more than one .NET language. Fine. I'll give you one example. With that, with that example, we'll stop the session. Then you can put forward your queries if you have any. Otherwise, we'll wind up the session. Right. Listen carefully. Now imagine we all, Ashwa, Hussain, Chaitanya, Nikhil, Sindhu, myself, Shareef. We all five are working in one IT company. Okay. We all make one team. We all five make one team. And in this team, Ashwa, Chaitanya are aware of C#.NET. C# they know. Nikhil, Sindhu, and myself, we are good in VB.NET. We are good in VB.NET. You are experienced in C#, we are experienced in VB. Tomorrow, if a company gets a project on .NET, right? So company will make Ashwak and Chaitanya to involve into that project of .NET. Even company will ask we three, Nikhil, Sindhu, and myself, also to involve in that project. though we both are familiar with different languages. One team is aware of C#, one team is aware of VB. No problem. No problem. .NET supports that. .NET supports that because we all are developing one project. We all are working in one project. Definitely, this may be a situation like what Ashwa has written one program in C#, and that program I need, which I'm writing in VB. C#.NET developed a program. I want to use that program. I want to link his program in VB. Or imagine that Nikhil has written a program in VB.NET, and that program Chaitanya wants to use in C#.NET. So you can link the programs cross language. C# can link with VB, VB can link with C#. You understand? For that process, that concept is called language interoperability. But now you need to know how this is possible, how language interoperability is possible. For that, I'll explain you with architecture in my next class. We have something to learn. We have something to learn about one more component of CLR. Today we covered one component of CLR as JIT compiler. Similarly, we are going to cover one more component in my next class connecting with the CLR. Okay, and explanation to that component will make you understand how language interoperability is possible in .NET. Okay, that's it. Tomorrow's class we'll complete this feature